Hello everyone, my name is Amisha binti Zamani, and this video I will talk about answering the question regarding to part 1. So the first question is, did you identify any systematic error of the equipment and explain what you do to rectify it? My answer regarding to this question is yes, and the systematic error is incorrect calibration, which reduces accuracy. Certain value is allocated to a certain point on the scale of a meter. The apparatus that used in the laboratory are commonly calibrated in the factory at certain temperature, humidity, and magnetic field pressure. If we use in different conditions like in laboratory, the calibration is no longer valid. That will cause discrepancy between two data. And I rectify it by finding the standard error. So for the next question, which is question 2, can we improve the precision of an experiment by increase the number of measurements? And explain your answer. So my answer regarding to this question is we can increasing the number of measurements in the experiment, because the more measurements that are taken, the closer we can get to knowing a quantity's true value. Random error will be smaller with a more accurate measurements are made, because the more measurements that are taken, the closer we can get knowing a quantity's true value. So for the third question, the question asks me to explain what is normalization condition. So in this question, I attach two photos of bell curve on a histogram. So regarding to this question, different measurements have different distributions. Not all of the distribution having symmetrical bell-shaped curve, like the shape that can be achieved from the histogram. As the number of measurements approaches infinity, their histogram approaches some definite continuous curve described by a definite continuous function, say px. When this happens, the continuous function px and the corresponding curve is called the limiting distribution. Note that limiting distribution cannot be exactly produced in practice, because this would require infinitely many repetitions of the measurement of quantity x under identical conditions. However, there is overwhelming evidence that for almost all measurements there exists a limiting distribution which our histogram approaches more and more closely as we make more and more repetitions of measurements. Since the limiting distribution is a limiting form of histogram in the limit n approaches infinity, the following interpretations are easily understood. Px dx equals to the fraction of the measurements falling between x and x plus dx, which is integral a to b px dx equals to fraction of the measurements falling between x equals to a and x equals to b. If in addition we impose the requirement normalization condition that integral negative infinity to infinity px dx equals to 1. So that's all from me. Thank you.